Welcome to the September meeting of the Dallas Personal Robotics Group. The only news item I've got is that Robo Columbus, the date has been set for Robo Columbus. That's our annual outdoor competition where we attempt to get our robots to seek to a cone and touch them and go around an outdoor course that's about 100 yards between cones. 3 cones. So the date will be November 22nd. And that will be in place of the usual monthly meeting. So those of you online, feel free to chat. Mark is running our AV system here, and he'll speak for you if you have any questions or comments. I've got my sound turned off. So I want to welcome the groups, the folks from UT Dallas and from UT Arlington. We've got today we're fortunate to have club members from the robotics clubs of both of those universities. And thanks to Dave Dubay, who we're talking about how what might make sense in terms of some kind of is there some way DPRG can help the clubs can help DPRG, whatever. So we'll talk about that at the end of the meeting. But I want to welcome you. Let's see, does anyone have any questions before we jump to the first presentation? Oh, okay. Karim, are you ready to go?
I am not. Maybe you should go first.
Okay, I'll tell you what, because you're
switcheroo.
Yeah, well, we can do a switcheroo, but I segmented my presentation so that I can break at various sensible points. So holler at me when you're ready to roll. All right, so Karim is going to demonstrate his robot talking and understanding commands in real time, which is ultra cool. Okay, so then I'm going to introduce you to maybe some things that you don't know about Git and GitHub. I hope so. I'm going to go over the basics, and then for those of you who know Git, I'm going to go over some advanced commands to try and deliver some value to everyone who uses Git.
Are you sharing the screen?
Someone commented that your mic is off. Someone did comment a minute ago that your mic is off.
Really?
Yeah.
It should be on.
Oh, yeah.
Yeah, you can hear Paul.
So yeah.
Little microphone.
No, that's fine.
Oh yeah, my microphone on my PC is off, but audio is coming
well.
through the lavalier to that PC, which is going out on the web meeting and getting recorded.
Mm-hmm.
Yeah. Okay, thanks for the heads up. Okay, let's share my screen.
That's the next thing.
I did already. Oh, and they can.
Yeah, they can hear Paul.
Okay, is my screen coming through?
Yep.
I wish I could get this thing hidden. It's big and in the way of everything. Okay, so we'll break to Karim's presentation because I suspect his topic will run long because he's got a lot of really interesting stuff that generated a lot of interest last time and probably will again. So a conceptual overview of Git and GitHub. At the physical level, at the physical level, you've got GitHub in the cloud, and GitHub is run, as you probably know, by a company that's owned by Microsoft. And then you have your PC. At the logical level, can start at the bottom. You keep a repository on your local PC that is files that you can edit, and files whose changes are tracked as you make changes. those get backed up into the remote repository in the cloud, and they're backed up by an operation called push. Naturally, you push stuff up to your repository in the cloud. You can make changes. If you can also pull changes down from the cloud. Or the word clone has a special meaning. It means make an initial copy, an initial local copy, create a local repository that is a copy of the cloud. So your goal as a Git and GitHub user is to keep your local and remote repositories in sync, and I'll explain why you care about that here in a tick. But first, I want to introduce one more concept, which is an optional upstream repository. So that's a set of directories and files that you fork into a remote repository that you own. So you do this if you want to make changes to somebody else's code base. For example, imagine you've got a geographic library that you found on SourceForge, and it's only available as source. So there's two paths you can go. One is to just clone it down onto your PC, and that's an appropriate path. If you just want to use it as is, you don't need to make any changes. If you want to make any changes and save them to the cloud, you need to fork them, meaning that you acquire a copy of that somebody else's remote repository, and you can then clone it to your laptop and then make changes and push them back up to your copy in the cloud. They don't go into the other person's copy. So it's a way of this upstream and downstream notion is a way of passing down ownership or passing down source code with the ability with giving you the ability to modify your copy of it up in the cloud by cloning it, making changes locally, and pushing it back up to the cloud. And I'll explain why you would want to do that in a bit.
Hey, Paul. Can't point out there's a hide button down the bottom next to stop sharing. To probably hide your, it's behind that little window. Yeah, that. That doesn't hide that. Okay, interesting. Never mind. Oh, there you go.
Okay, so the Git commands that we'll talk about manipulate the local repository and its version history, and provide for syncing it with the cloud version. That's the remote repository, or we call it a repo for short. It's always called a repo. And they provide for syncing it with the cloud version through the push, pull, and clone commands. Git is really the only thing that anyone uses for source control these days. There used to be Subversion, and before that CBS, and lots of ones. They've all gone the way of the dinosaur, and Git and GitHub is the thing. And what Git does is, what GitHub does in the cloud is it provides for creating new repos in the cloud and for interacting with optional upstream repos like by doing forks and pull requests, as shown here. And that's how you can contribute to projects. So, for example, I'm contributing to a robot software project called Lino Robot. So I forked Lino Robot's code down into my own remote repository, my own GitHub remote repository. Then I cloned it down to my PC. I make changes, I push it up to my repo, and then I submit a pull request to the remote repo. And that's how the owner of the remote repo keeps control of what goes into their repo. They don't have to accept my changes. And there's a whole process that I won't go into in this talk for like commenting on changes. Okay, can you add this feature or whatever? But what Git does is it tracks diffs between versions. So it keeps diffs of text files, and that helps keep commit sizes small. Line 23 had this added, line 24 was deleted. It does support binary files, so you can use it for saving your PDFs, your schematics, your circuit board designs and 3D models. I don't know how it keeps track of diffs, and I really don't care. No one cares about diffing binary files, but so that's at a conceptual level what Git does. Does anyone have any questions on concepts and terminology before I move on?
You guys use Git on your projects?
Okay, good.
How many software people in the room?
Excellent. So why as individual developers, be we hobbyists like myself or students, whoever, why would we use Git and GitHub? It's a question that often comes up in the DPRG. Why would I bother to learn GitHub? Well, Git and GitHub. Well, robotics centrally includes software and firmware, so you really need to use proper techniques in its development. But that comes with some overhead in managing local and optional remote repos. You don't have to have a remote repo. You can use Git just locally on your PC. Just make a Git repo. You can check stuff in, but you lose some things if you don't push it into the cloud. So the first bullet here is why the cloud backup of your code saves you if you lose your code folder on your PC through any number of mechanisms, be it a disk corruption or you fat finger rm-r. It's a lot harder to delete a Git repo than a directory on a PC, and you can recover from that.
Yeah, with the Pi, you want to worry about your SD card.
Yes, your SD card can get corrupted. So if you got all your hard work up in the cloud, you can easily restore it. You can save intermediate working states of your code and easily get back to them for testing. So you can do code advancements on your local PC, but as long as you committed to the cloud a version that was your last working point, you can always just get back to that, check it out, and and then you can test whether you broke something or whether the hardware broke. And that's always the question when you're always the issue when you're dealing with robots, right? The hardware is always unreliable, and when you make a code change and your robot doesn't work anymore, you never know for sure whether it's because the code change broke it or because the hardware is just unreliable, because prototype hardware always is, and the hardware broke. So that lets you get back to easily switch back to the last working config. You can switch between multiple configs, for example, between 2 robot configs or 2 sensor configs just by switching branches. I'm not going to go into branching this talk, but I think I'll do it next meeting. But branching is its whole own area of Git. You can avoid multiple copies of code directories syndrome. So not to poke fun at any of the members, but I got a code base from one of the members, and there were two directories, robot code 1 and robot code 2. Well, what's the difference between them? And so then I diffed the directories and found there was no difference between them. Well, if you use Git, you just don't have to even worry about that. You just check out whatever, make changes commit the changes, then you can go back to any version you want. So easily make changes to test something without changing the known good version, which is difficult without using multiple copies if you're not using Git. And a lot of people in the club still do keep multiple copies of and they get something working and then they copy that away to last good September 25th. Don't do. That's so useful. fearless refactoring, or trying out new libraries and features. So Git encourages bold changes because you can get back so easily to something working. So you can start a major refactoring on a branch and abandon it if it doesn't work out. So that gives that safety net, gives you confidence to try big changes. More reasons to use Git and GitHub. You document changes versus documenting lines of code, for example, with a comment in the code. And you document them with comments in the commit message. So that supports long-term project archaeology. Like months or years later, you can go back and understand not only what you changed, but why you made that change. Another reason to use it is it enables syncing your code directory between multiple machines. So maybe you've got your code down on a Raspberry Pi and you're also developing it up on your laptop because it's just easier to work on laptops oftentimes. Depending on your editor, if you're using VS Code, then you can do remote editing. It's almost as easy. But if you're not, there's a lot of scenarios where you want your code, you want the current version of the code both on your laptop and on your robot computer. So you can sync your code. So that way, if you push it to GitHub, you clone it down onto your robot computer. You can make changes on your robot computer as you discover, oh, I got the pin number wrong. Push it back up to the cloud, then pull your change back down onto your laptop and carry on the laptop. So then it lets you use the GitHub version of your code as a master repository with the two computers being clones and each able to push changes to the GitHub repo. And if you do what I often do and make different changes to both of them, it'll warn you when you try and push to the cloud. It'll say, "Oops, you're not at the head. You need to resolve this." So gives you a good way to sync code between two computers. You can maintain a release version that's always ready to run while you go ahead and develop on a branch. So that gets you, so I talked about this before, isolating when a problem arises, whether it's hardware or software that broke. And you can maintain version controls of hardware files like CAD models and PCB designs, as well as software and firmware. So, tools. What tools do you need to get started? Well, Git is multi-platform. Runs on Windows, Linux, Mac OS. Runs on x86 and ARM. You'll want to install Git on your platform, and if you following the video along afterwards, make sure you check that you've got Git K. It should come, according to my reading, it should come with Git. I'll show you what Git K is when I get to the demo portion. But that's really valuable for understanding the history tree. You don't need the GitHub CLI. You sometimes find references to that. It's called GH. Use the GitHub website for all your operations that you do with remote repo. If you use VS Code, all the Git extension, it does lots of good things for you. I don't personally use it, but some people do, and it's good stuff.
Yeah. So Paul, just a quick comment. One of the really neat features of the extension in VS Code is you can go past the text on a line, and it will tell you who made the change and when it was last made.
Yes.
Very, very nice.
Yes, that is nice.
And one of the tools I use is the GitHub desktop. Windows has a GitHub desktop that's really useful.
Yeah, yes, thank you. If you're running Windows, GitHub desktop. You're going to want that. I don't run Windows, but thank you for that, Mark.
When you're finished, I can show VS Code with GitHub. I can share my screen.
If you don't have a GitHub account, create one at github.com. and you'll have to set up SSH keys and two-factor authentication, but that's easy enough. You need one.
It's all free.
How are you doing? Let's see. Are you getting ready to go?
Yeah, I can.
Or I'll tell you what. I've got 2 more slides, and then I'm at a real good breaking point. So this slide is, you don't have to remember this, but both Windows and Linux have a .git config file in your home directory, and here are some suggestions for some things to put in it. You'll always want your user email and name. That's what gets applied to the check-in each time you check in. I've got 2 aliases that I use commonly: S for status and CO for checkout. If you put this in your .git config, it's a global command, and then you can just do git S. It's the same as typing git status, but 5 fewer letters, and same thing with git CO for checkout. Then in the diff section, I suggest that if you don't already have your own favorite tool, get Meld. Install Meld. It's available for both Windows and Linux. It's a great tool for both diffing the changes between what you've changed locally and what's in the repo, as well as for doing merges and merge commits. So then diff tool, meld, and merge. The tool is meld. So these are some things that I recommend for putting in your .git config. And you can make other aliases if you want. Yes.
Okay, that was my question.
Yes, you can make other aliases. I've been thinking I should have an alias for commit, but I haven't.
I have one for FA, which is fetch all.
Oh, okay.
I use the git ignore button to keep noise out of GitHub.
Yes. Thanks, Mike. That was a good segue into advanced Git use.
Yeah.
So git remote -v is real helpful for telling you where. So if you're not a Git beginner, then these might give you some help. Tells you where the remote repo is, and that can matter. Oh, by the way, these slides will be available on DPRG.org on the web when we put the video up. And I should have mentioned before we're videoing this, if it's not obvious by now, if you don't want to be videoed, put a mask on or something. The .git ignore file that Mike talked about configures files and directories that should be ignored by Git. Because one of the frequent things that you want to do with Git is find what files did I change in the process of messing around with whatever I was messing around with in the code base. Well, the trouble, that's fine, Git status will tell you what changed, but a lot of tools like Python will put a .pycache in or a pycache directory inside of your source tree, and you really don't want to be alerted about changes to that. So you can enter wildcards in a file in your home directory called, a file in the repo, in the base directory of the repo, called .gitignore, and it will ignore directories or files named there. So, for example, you put pycache in your .gitignore, and it will ignore the pycache and everything under it when you do a git status. Git push -f does a forced push. That forces the remote repo to match your local repo. Sometimes you need to do that. For example, when you've got 2 computers and you pushed something to one and you shouldn't have because the one you really want to push to the cloud is on your other computer, push -f. Git revert backs out a commit, and do a Google on how to use it. You can back out a commit both locally. Locally is real easy. You just revert it, and then your change is gone. And you sometimes do that when you like start typing and then you realize you've totally trashed everything and you just like committed it, and then you don't like that. You want to back it out. If you pushed it to the cloud, then revert it locally and push -F up to the cloud. Git cherry pick is, and then a hash number is useful when to pull a single commit from one branch into another. So if you've been working along on the main line, but you had a branch that you were experimenting with, and you made one change that you really like, but you don't like what's in the rest of the string of changes that you committed on the branch, cherry pick that one commit into the current branch. Git blame is a great command. It's what Mike was talking about that you get in VS Code, where you where he said when you move over to the right-hand side, it tells you who changed what line. So you can find out in shared repos or in repos where you're a maintainer, or someone else has been changing it, who did what, who made the change for each line in a file. Squashing. It often happens, particularly I find with documentation, because documentation is never right. It can always be better. And so, you know, I type away some documentation, I do a commit, I work away on some more, do some more documentation, do a commit, and then at the end of it, I've got this big long string of commits that are like edits, made some changes, edits, that just are untidy and really have no value in the history. So if you do git rebase -I, head ~n, which is how far back in the history you want to squash, it brings up a menu that lets you select squash this commit, this other commit. You can squash them all except the last one, and it'll collapse them all. By default, it'll merge all the commit messages into one. So it's a real good way of just making your commit history tidy. And the final one I've only used once, but it can be useful. Git bisect helps you seek to the commit that broke something. So imagine you've got 50 commits, and you know something used to work, like back in January, like your IMU. You remember your IMU worked, but here we are in September, and damn, the IMU doesn't work. Okay, and you've got 50 commits between here and there. How do you find where it got broken? So the way you do it is you're on the head. The assumption is that the head is bad, and you have some test that you can do that tells you whether whatever it is you're looking at is broken or not. So, for example, you dump the IMU data. So then you run git commit and give it the hash of where you last knew it was working, back in February or whatever. Then it will pick the midpoint between the current commit and the February commit that you gave the hash of, and check that out, and then you run your test and determine if it's good or bad. Then you run git bisect good or git bisect bad, depending on whether the test showed that it's good or bad. And then it will check out something either earlier, if you told it git commit bad because the breaking change must be earlier, or the midpoint later, if you told it git commit was good. So it does binary division to work your way through a string of commits to the commit that broke your IMU or whatever it was. So at this point, I'm going to switch to doing demos, but I think we're going to switch over to Karim's presentation now, and let him talk about how he makes robots listen and talk. Dave.
I'm sorry, I should have asked this during questions, but maybe could you, since we have students here and they're not familiar with the club, can you give a quick overview of DPRG? What's in scope, what's out of scope, what you guys do, when do you meet, how many members are there, et cetera? Who, why, what, when, how much?
Thank you. That's a, yeah. I thought about doing that and I forgot. Thank you for that prompt. DPRG currently has between about 30 and 40 paid up members. We have probably about, we have almost 90 people that I would say are in our community in the sense of being either on Discord or on our email reflector. We're centrally based in the DFW area, but thank you. And we hold monthly meetings here, but we've got folks who are both members and which we greatly appreciate, members who support our efforts, and all over the country and in Canada. And we hold a number of activities. Every Tuesday night we have a video call where people will say, okay, here's what I've accomplished, what I've got to show. It's like show and tell, except online. So it's online using GitMeet. And you can find the link for that on dprg.org. There's always the link to the next Robot Builders Night Virtual is what we call it. So we're robot builders. We gather at night and it's a virtual meeting. We have 2 annual competitions. In November, we have an outdoor competition held at a member's location. We'd love for you all to come and watch and participate. Bring your own robot. All of our events are open to all, so we welcome everyone. So you might say, well, why should I be a member? Great question. Because you get to help guide the club. Questions about the club's direction, things that we should offer, things we should do. We take votes from members only. And we appreciate our paid up members for supporting our work. Yes?
Is the DMS membership different from the DPRG membership?
Yes, it is. So the DPRG is a separate organization from the Dallas Makerspace. We use the Dallas Makerspace facilities here, and we greatly appreciate the Dallas Makerspace. We have a long relationship with them. Some members of just a historical note here, some members of the DPRG founded the Dallas Makerspace back in, I think, 2010. I'm sorry?
Yeah.
Celebrated 15 years. Yeah, right. But, you know, they are separate organizations, and really they need to be that way because they have very different models, different membership models, different value models. The DPRG is centrally about hobbyists building autonomous robots, gathering to share their experience with them, to compete them on occasion, to gather socially, to listen to tech talks, give tech talks. The Makerspace is centrally about providing a place where there's specialized equipment that you couldn't and wouldn't put in your house. And it has a very different fee structure because it's got this nice big building with all the equipment that needs to be maintained. So, you know, the 2 organizations are very different, should be different, are cooperative, collaborative. We love the Makerspace. The Makerspace seems to like us, and we hope they keep liking us.
Could you bring up the DPRG webpage?
Yeah.
Maybe can you talk about what's a robot? So does that mean land, air, water, or how do you define robots? And what do you guys focus on?
Yeah, great question. Thank you. So I mean, we all have our own notion of what robots might be, right? And but the DPRG's focus is centrally on autonomous land vehicles. We have some members like Karim who's working with arms, and we welcome anyone who's working on like other types of robots. But we don't have members currently involved in like UAVs or AUVs or subs or not that we would say no, we're not interested in that. But what we are really centrally about is autonomy. And so I'll just draw a little picture here that is Paul's view of the world of people who play with robots. So robotics centrally involves mechanics, electronics, and software. Those are the three main disciplines. So, and people generally are mechanically inclined, electrically inclined and experienced, and software inclined and experienced. And there's crossover. Personally, I tend in this space. My first degree was in EE. I now do software, but others are mechanical. And so my view of the world is that these MEs and EEs can tend to gravitate towards teleop robots. So think BattleBots, something remote controlled, because it's really not that much that goes in the software goes on in the software space. You can have some accelerator buttons on your remote to, like move an arm or whatever, but it's not centrally about software. And the EEs and software folks can tend towards autonomy. Autonomy meaning you give the robot a mission and it goes off and might do what you want. Sometimes. So that's Paul's view of the world, and I know that the UTD Robotics Club is heavy into teleop BattleBots. You do have some autonomy, but this is my view of the kind of people, and people have different interest rates, and where those tend to land, where those kinds of people tend to land in teleop robots versus autonomous robots. As a club, we're really about autonomous robots. Our competitions are all for autonomy. What?
Competition stuff. Sort of give an overview.
Yeah.
Basically, we have a Roborama every spring, and that's multiple indoor competitions. And we have a Robo Columbus in the fall, which is coming up in November. And that's an outdoor challenge. You'll see a traffic cone back there. This is a challenge where your robot has to autonomously navigate to traffic cones that aren't visible from each other necessarily, and make it back to the home base. And there's a point system associated with it.
And you guys have, for the two competitions, do you have different specifications for the robots? And what are they?
Every single event, and so Roborama has multiple. We'll choose from our roster of different kinds of competitions. We'll probably choose 5, 6, maybe 7 of them for a particular spring competition, and each one of them has its own rule set. And some of them are more narrowly defining what kind of specs your robot is allowed. Like, obviously, you can't, well, I'm doing it right here, but you can't have a 50-pound robot on a tabletop competition, right? And their dimensional sizes and things like that. So,
yeah. The sumo challenge.
Yeah. I'll take your sumo. Fall competition is wider open. Do you want to speak to it?
So fall competition is Robo Columbus. I forget if there are dimensional limits, but
they'll be overlooked if you have
to
have a robot and it works. We're not that stuck up about those particular kinds of rules. It just has to be safe, right? You can't be rolling over people and stop them to that.
Yeah. And so safe meaning if it's fast, then it ought to have a stop switch. But if it's slow, then we count on you to be able to like run after it and pull the battery apart or something. So our competition master is not here today. He's off gallivanting around the country somewhere, but he's the final word on what's acceptable. But you can always check in at a Robot Builders Night virtual and say, hey, I'm proposing to do this. Specifically, one point to note about the November Robo Columbus competition is RTK GPS is allowed, and I won the last year competition with an RTK GPS robot. And
an inside job.
That was not an inside job. The thing wasn't working properly till the day before, as is always the case. Okay, anything else?
Carl wants to point out the YouTube as well. DPRG
Yeah.
clips.
Okay, so if you go to YouTube,
Keeps disconnected.
DPRG clips is the channel for the DPRG, and
Do your clubs have YouTube of your competitions you've been in?
Mhm.
Yeah. Type in GTA over.
okay. Okay, this is having trouble loading.
Yeah.
I have a question. So for participation in the event, is it only for paid DPRG members?
Nope.
Or
It's open to everyone.
okay, was there a participation like
Nope. No. And to make it even sweeter, you can win prizes as a non-paid up member. I tried to change that, but they wouldn't let me.
prizes are old broken robots?
No, you get real prizes like for first wins $50 or second wins 40, third wins 30, or as an alternative to getting taking money, you can actually you submit a receipt for robot parts that you build is really how the prize system works. But you can trade in your prize for a DPRG membership, and we love that too. So our DPRG clips has videos of all of our Tuesday meetings plus the monthly meetings. This is March. So anyway, look at dprg.org, look at YouTube, and you'll also find on the DPRG website, this is under the news section, get the latest news. Don't know why it's called news, but well, that's a whole different story. You'll find the meeting announcements, and then you'll find the videos for the last few meetings. So there's the video for, YouTube video for Airbnb 16 September, and so these are all in order. So they'll come out a lot better. And here's the video of Karim's presentation last meeting. Okay. Anything else? Other questions? Before we hand over to Karim.
I'll go ahead and explain the robot in the meantime. This chassis is called a Pioneer 3 AT. It's an outdoor chassis. It's four-wheel drive. It's skid steer, and its purpose was to be a research experimental robot targeted at the academic community back in the very late 90s, early 2000s kind of a thing. And it was a very, very popular robot. It was out there, but it's on the expensive side. It was targeted at those communities. So, $15,000 roughly for, this kind of robot, and that's just the chassis and the internal controls and things like that, plus the sonar sensors. But
where did you get yours?
huh?
Where did you get yours?
I got mine off of an auction. So there's the robot waking up again. Ooh, I wonder if it's going to start talking. No, it wouldn't yet. I haven't figured it. So the yeah, I got it for considerably less than that. It was Air Force surplus. I can tell because the IDs were baked into the firmware. But yeah, I got a pallet of 6 of these. And so much cheaper. There's no suspension on them, but they are beasts. There are 4 motors inside, so they're ganged up on 2 on each side, and it'll just keep on driving. Yeah.
You mean to tell me this thing's almost 30 years old?
Yes. The chassis is.
Oh, yeah.
Yeah.
Just mind-boggling.
No, exactly. Like it was solidly built. There's no fault with any of the electronics, right? The low-level microcontroller is called Arcos that's in there. It was fully functional the day I powered it up, right? I just had to figure out what the protocol was because there's very little documentation on the low levels on how it works.
What about parts?
That's why I have 6 of them. And I plan to get a second one up and running pretty soon. This one's called Barney, and the next one's going to be Betty. So some of you will get that reference, and a lot of you won't. So I also have a WaveShare RoArm M2. I think it's the full name. It's just serial bus servos connected. This is a low-end, very low-end arm, but it is enabled on the ROS infrastructure, so it's a good way to be able to experiment. Like if you want to do industrial arms, that kind of stuff. This is a 4 degree of freedom unit, and it can't lift heavy loads, and it's not the kind of precision you're going to see in an industrial type of arm. But it can move so I've got the camera mounted on the top. This is an Intel RealSense D455. So it is a depth camera. It has 2 black and white stereo cameras plus a central color camera, so we can get data from all of those different kinds of things, and we can get an actual depth cloud if we need to out of that. It's also got GPS RTK. This is the mast is down right now for the sensor for the antenna, but that's basically it. So and then the project that I'm working on right now is to try and integrate it with AI, right? For voice-enabled conversations with the robot, both normal chat style, like conversational robotics, as well as AI conversations, as well as for it to understand what the robot is actually capable of doing, and then trying to issue commands when it hears the user speaking, right? And not necessarily me having to remember the exact command thing, but allowing the LLM to infer that I said something that implies this is the command I want to execute. Yes.
So those round circles, are those lights?
These are the ultrasonics,
Okay.
right? I don't know if you've ever seen an old style Polaroid camera, but this was the kind of sensors that they used on those. In modern robotics, usually in those much smaller ultrasonics, like the SR04s and things like that, there's a big difference between the 2 sizes. So basically, the size has, the larger it is, the narrower the depth, the angle that it detects, right? So the more modern sensors have a wider field of view, if you like. This one is a narrower one, and that's why you see that there's more sensors there. So there's an array of 8 on the front. I guess it went down and then it came back up again. And then there's an array of 8 on the back as well. And that's happening, those are fired in sequence by the low-level controller, and I just get the data from it. So there's also an embedded PC inside, which is sort of the brain of the robot. That's the thing that's running ROS.
What's the processor that, are you running an RPi that's, I'm assuming that you got on top of it?
This is a little bit, just a teeny bit more capable than an RPi. So it's
I'll take your number.
is a N1. It's the Intel NUT.
Okay.
So it's the 100 series. Forgetting the exact numbers. N100, something like that. It's a quad core processor. It's x86, and so that makes it nice and easy on the raw side of things, right? You're not worrying about ARM architectures, and it's just got slightly better support from the peripheral standpoint. Yeah. Okay. Guess I went through most of this stuff as well already. So again, what I'm trying to do is have a voice conversation with it. Let me see if I can use this opportunity. You're live. You are live.
The operating system you use. What operating system do you use?
The robot is running Linux, Ubuntu 22.04 right now. In RAWs, they have a very strong association between the Linux version and the RAWs version in terms of what is considered supported. Quite often, they will work just fine across a limited set of versions, but they give you absolutely zero support on it. So it's like you really want to stick with the matching version of RAWs that we're running. So I'm running RAWs humble on this robot. That's an unfun thing to be showing to the viewers. So come back over here while we wait on it. So so one of the I tell you what, we're gonna try live something different. Can I do this? We're gonna search on how many of you have used Gemini? And how many have used the Live API? Do we know what the Live API is?
Is that what we go directly to Gemini?
So any API calls. So there's difference between using Gemini through a web browser and chat interface versus through the API where you're making calls across the web at a low level from your whatever your programming language of choice is, right? And then there's multiple APIs. So one of them is the normal chat API, and then another is called the Live API, and this is optimized for real-time conversations. So let's just look at Google AI Studio. How many of you have used this directly? You kind of do if you're using the chat interface, right? But this is how you can experiment with the Google AI products, which are mostly the proprietary ones are called Gemini, and open source ones are called Gem. And so you can get access to all of those and experiment with them through this. This is a completely free product. You don't have to pay anything for it. I don't know when limits will start being applied, but right now it's free, so you can just sort of register as a developer. Normally you would come to this chat interface right here and go to that. We're going to go to stream, and so this is you see it says Gemini Live. So this is how you can experiment with how you set up your prompt, how you converse with this thing in order to be able to sort of get a better sense of what its capabilities are. And I don't have a webcam hooked up to this laptop right now, but I can, let's see, we can do a share screen.
There's quite a strong emphasis in the DPRG currently, just filling in space while Karim is working on things on AIs, using AIs for a variety of things, from cone recognition to coding, different code assistants like the one that's built into VS Code. Copilot, Copilot, and Ada is a standalone one, and so as opposed to the cut and paste into a web browser, working with tools that natively read your files off your laptop and write files.
It's really cool. You can open your whole thing, your whole project with multiple like files of code and VS code, and it's like, hey, how do I add this to it?
Hey, Karim, how did you do that? Do you have a Bluetooth speaker up there, and you just tapped into the commands the Bluetooth speaker, or?
It's not a Bluetooth speaker. It's Bluetooth capable, but it's just plugged in via USB. So it's acting like a speakerphone. It has a microphone on board, and that was important because it's got built-in echo cancellation, and that's really important if you're in an ambient environment with multiple voices going on.
And you just tapped into the command line to give a different command?
It's just acting like a microphone and speaker to the Linux operating system.
But you give it commands verbally, so it listens to that through the microphone.
Oh yeah, the robot. Yeah.
Yeah. How is that translated into the ROS?
So so ROS has a node called that is the audio capturer node, and it takes anything that comes in from the microphone, and then I have a node that takes those audio messages, runs them into Silero VAD. You know what VAD is? It's voice activity detection. So that's what says, you're not listening to a vacuum cleaner, you're actually listening to somebody speaking, right? And so that, once it detects a human voice, then I send that on up to to my bridge, and then out to my agents, and then they send it on to Gemini or OpenAI's version of a real-time API.
And you have to have specific commands, no out, sit, stay, down,
You do have to create a vocabulary for your robot, and that's going to be very robot specific, right? It's got to know which commands you're going to have. So, and that I can show you at least on the. Let me take this opportunity to just one more chance at seeing if we can.
Why are you connecting to Gemini? Why do you need Gemini? Why don't you just run it all off the onboard?
That's a very weak processor, right? It's already close to maxed out just doing this normal ROS stuff.
So if you upgraded it, you could do that.
Yeah, that would be a very significant upgrade, especially for like, it depends on what level of AI you want access to. If you want, so one of my use case was, I want access to the best of breed top, frontier models. Right, and because my robot is usually connected to the internet anyhow for other reasons, then that was the way to go. I don't have to worry about any kind of local compute. I just have to worry about paying for the service. And so far, I haven't had to pay anything for Gemini. And I started out with OpenAI real-time API. That might be slightly better at processing language, but they never got around to shipping video or visual processing as part of the bundle. They've been talking about it for a year and just haven't gotten that. But Gemini does both, so it's fully multimodal, and that's why I went with. That's why I'm using Gemini right now, because that's the only thing that will let me look at the camera.
So if you lose your internet connection, your robot's down.
It's down from the standpoint of having a voice interface to it.
Okay.
But the rest of it can continue to operate. So if I've got it running running its rounds on as a Sentry robot between waypoints, it can still do all of that stuff.
Thanks.
But it wouldn't be able to cross the trespassers.
Sure. I mean,
you warn them in a very friendly and nice way that you're not in your right spot, right?
So if you put it on Robo Columbus in the fall, with the feed,
yeah,
it'll still operate. Just your voice commands won't work if you're not connected later. Is that correct?
That's correct.
But you wouldn't need voice commands because it's all auto.
You don't need voice commands if you already have some explicit mission defined, right? Yeah, it's just an extra modality that you can add on top of the robot. So I don't know why you decided to do that, but decided to do that, which tells me Tell me what you can see. Actually, we should have got some audio out of that. Hey, robot. See, it's working. I don't know why I'm not getting audio. Oh.
There's a man with glasses and a patterned shirt looking at his laptop. He seems to be in the middle of speaking or reacting to something. Another man in a blue t-shirt is looking directly at my camera. He is seated at a desk with a lap.
Pan left. Robot?
Who's right? There's a man holding a tablet-like device. You were saying something about not getting hammers. Could you clarify what you mean by that? Hello, I'm Barney, a skid steer robot. What can I do for you today?
Stand tall.
Okay, standing at attention.
Look to your left.
Okay, panning left.
What do you see?
I see a group of people sitting at desks in a classroom. There's also a fire extinguisher on the wall to my far left.
Do you see anybody holding up anything orange?
Yes, I see someone in the back holding up an orange traffic cone.
Can you put it on your head? No, it's all right. It's all right.
I am a robot and do not have a head to play top of. I also cannot my head is my camera, which is part of my arm, so I can't put the cone on my head.
Can you tell me kinds of things you can do?
I can move around, turn, and pan my camera. I can also track and follow objects.
Sure.
Hey, who's the one talking right now?
I am Barney, a skid steer robot. I can move around, and I have an arm with a camera that lets me look in different directions.
Hey, tell me, what person is speaking right now? Is it the guy in the light blue shirt?
I don't know who is speaking. I am a robot, not a person.
So yeah, I mean, it's not looking directly at you right now, and actually I can share the video of what it's seeing.
And the camera.
So you can see that it actually can't see you at all right now. And
Panning.
can you pan right?
My camera is panning right now.
Okay, who is speaking right now? Is it the guy in the light blue shirt?
Can you describe a person who's standing?
Sorry, I don't know who is speaking. I am a robot.
We're getting that. Can you describe somebody standing? I guess not.
Is it using the video as context or just still captures from the video as context?
I see 2 people standing and 5 people sitting in the room.
Amazing.
I process the video frame by frame, so it's more like a series of still captures rather than understanding the full video as a continuous context in the same way a human would. What would you like me to look for in the current frame or the next few frames?
Look for a guy that's in a light blue shirt.
I see him.
Maybe next year we'll get this all.
I see a man in a light blue shirt standing behind one of the tables. He is on the left
crossed?
side of the room.
Are his arms crossed?
No, his arms are not crossed. He is standing with his arms at his sides.
Is
So
he
you
still
can
there?
see this is incredibly
What else can I help
capable,
you with today?
right? This is very. Oh, can you go to sleep, Barney?
I'd have to say I'm impressed that this is even possible. I mean, free. When 2 or 3
I'm
years ago,
glad
you couldn't
you are
get anything like that.
I'm designed to be helpful and informative. Is there anything else you would like to ask or discuss? It's great to be able to interact with you all. I can see several people in the room, and I'm ready for a conversation.
I can also query it via text as well. So there's ways that we can inject commands from an alternate source that's not the person that it's talking to. So going back to that scenario of it being a sentry robot, you know, so my plan is to have this. I've got a 900-foot driveway, right, with bends and turns. It's very, you can't really see to the end of it, that kind of stuff. So I want this thing to be, you know, have its rounds going up and down that driveway. And if it recognizes a person that shouldn't be there, right, I want it to go up and introduce itself and say, hey, I like you. I sent your image to the police or something. Yeah.
That's magic, though, Karim.
And then I also wanted to like alert me wherever I am that there's somebody who's not supposed to be there, and so I can send commands or inject my own voice in order to tell it what to do next.
And all the voice that comes out of it is all through AI Gemini.
That is all generated by the Gemini 2.5 model.
Yes, that's why you need the internet connection.
That is why you need the internet connection. So there are a lot of people who are doing similar stuff with fully local excuse me, embedded AI, and I'll be experimenting with that as well. And that is getting increasingly sophisticated as well. There are no local smaller versions that would fit on a mobile robot when you're worried about kind of power draw and stuff, space consumption, that have the level of sophistication. What you just witnessed, like how much you can infer from a scene and actually understand what's going on. You know, you think about the older machine vision models, right, like YOLO, V8 or whatever, that kind of stuff. And they're trained on a very limited set of known types of objects, right? But understanding in context, guys' arms are folded or not folded, that kind of stuff. There's just like, there's a whole different level in these cloud-based things.
Yeah, it's real-time interactive.
Yeah, and so what I didn't really get around to sort of explaining is that the whole idea here is the live API on Gemini and the real-time API on ChatGPT or GPT-4, they're completely different from the standard back and forth text-based prompt kind of interaction, right, which are stateless. This is a stateful connection, so you have to approach it completely differently. So, and it just requires a lot more plumbing, real-time monitoring of the different kind of traffic that's going back and forth. So it's a little bit of, it's definitely a bigger lift. So my repo is now, you know, almost 10,000 lines long in order to be able to handle this stuff.
Is the voice stream audio remotely, or does it come in text and it's converted to audio?
Yeah, so that's a different modality you could choose to do. Actually, we go back to the. And Paul, if I'm running too long and we need to get back to the other
Take
stuff.
as much time as you want, Karim. I think this is like magic stuff.
Yeah.
I mean, no one's doing anything like this that I've seen.
He's working.
Yeah.
Finally,
Would it be easier to use like an Alexis type of system where you just put Alexis on board? You know, because that's
so this is sort of an Alexis type system in that even when you're doing Alexis, it's not doing a lot of local compute.
Yeah.
It's relying on its cloud connection, right?
Right. And it doesn't have a camera on it, doesn't have an arm.
Right, yeah, and you can't really manipulate the world around it. We're now getting into where you can begin to manipulate the world backed up by these AIs. And there's the problem is my presentation, my full presentation is like 2 hours long, so we gotta pick and choose what we want to actually talk about.
So how about the students? Is anybody doing this at either universities? No. Really? Okay.
We were talking about how we can talk about
And then with the drone. That's where I want to see the company. Mobile with the drone. You can sign up onto our.
Send the drone up to scout around.
You can tell I'm Air Force. Forget the ground force. Let's put it in the air. Paul, how do I get signed up on Discord?
Let me.
You can put it on the whiteboard.
Great idea.
Brings the man. So how many hours do you think, Karim, you put into this?
Yeah, it's been 2 solid months of work. Yeah.
Probably hire a guard for last week.
Oh, absolutely. There's going to be a long time before this kind of stuff starts actually having a rate of return on it. But, well, you know, unless all of a sudden you get like noticed and then people want to start throwing speculative money at you, kind of, you know, which is happening a lot in the AI space right now. There's something that I wanted to, so if you guys, particularly in college students, right, if you're wanting to go this route, there's one big warning in terms of how you get the AIs to cooperate, because it's very difficult. I mean, we all experience this on a regular basis, right? They go off on their own. It's hard to corral them, make sure that they keep going in the right direction. I spend like 80% of my time working with AIs, managing the context and keeping them on track, right? Because they keep, especially the more complicated the problem that you're working on, they start to lose their way. And so I'm running into the same problem here with these real-time APIs in that, so let me go back to if you look at conversations, natural language conversations between 2 people, right, they look very different from barking commands at somebody to do something, right? They have very different features. So you can like reference this and we will share out the slide deck afterwards, and you can sort of go over fine details. So I'm going to skip through some of this stuff kind of fast. But the fact is that they are modally very, very different types of things, and AIs have a hard time. My initial approach was ask it to do everything all at once, right? Ask it. So I had to build in modes in the prompts and say, you're in command mode if you hear something that maps onto these specific types of commands. And then in that case only, you need to send back a JSON list of objects detected or a detected command in a very specific format, because that has to be parsed downstream by the actual low-level stuff running on a robot to turn that into physical behavior. But if not, they're just asking to like be told a story or talk about whatever is topical. Then you have to have a different voice mode for it, and the prompts look completely different when you look at them side by side. And I could not get an AI to like stay on topic and not be schizophrenic when trying to do something with multiple modes active all at once. So the approach I went was to build 2 agents. So I actually have 2 separate agents with 2 different sets of prompts for them that are operating simultaneously. So they both get the same voice input from me. They both get the same camera. I split it, send them both out, but they have completely different operating prompts, and I get back different responses from. And the responses that you get back are you're going to get multiple responses. So this diagram is showing. Oh wait,
I'll switch it back to you. but whoever was asking for a Discord invite, here it is, discord.gg, capital D, lower V, upper K, upper Y, upper D, upper U, lower Z.
Yeah.
Number
The
7.
appropriate way is
Take a
to
photo. Yeah.
convert that into a QR code.
Yeah.
And put it in the slide deck. Yeah.
Yeah.
Okay, so can I ask the obvious question, Karim? So I'm the business guy, but I got a PhD in AI, right?
Yeah.
What's this good for? What's the commercial use of this? How do you see this being used? Because the defense contractors are probably the state of the edge, leading edge for this type of technology, but it's all command or it's, it's joystick. So what do you really
Well, you
use
want
this
systems like that to be really closed, right?
Sure, sure.
And I can imagine all sorts of scenarios where this kind of thing goes completely wrong.
Sure.
Right.
But, I mean, they're like the
And
most
so-
advanced robots. So where do you see this commercially being used? Where it's
Well, so
interactive
this
real
is
time?
right. This is where you get into robotic interactions with the everyday public, that kind of thing, and it has to be very seriously gated by all sorts of safety mechanisms. Because the minute you're actually allowing your robot to interact with the world based on what an AI is telling it to do, right? You might have physical safety concerns, right? It may not. It doesn't always do what you expect it to do. We saw plenty of that here today as well, right? So I don't know what the near-term applications are. I know that we need to keep on improving on it, but there are going to be situations where you're going to have, increasingly, we are going to have robots in public spaces, right, interacting, and the minute that happens, you have to be able to interact with the people around you some way or another. At the very least, you're avoiding them, right? Or you're going into freeze mode so you don't have a risk of, hitting them or something like that.
Objects. Have you ever seen that video of that robot? I don't know if it's awesome, but it hit one of those cylinders that go up that's preventing people from crashing into sidewalks.
Yeah.
It ran into that and it fell over and it couldn't get back up.
Right. Yeah. Well, and there's another thing that we sort of didn't really approach is that the whole humanoid robot thing. And I would say that the club here is a little bit less interested in humanoid robotics. Maybe that's partly a cost thing, right? It's obviously going to be much more expensive. The more degrees of freedom you have, that's like a direct correlation in cost. But even those are coming down in price rapidly, and you can get a lot of utility out of those.
Yeah.
But the club is more interested in rolling robots, basically.
Yeah, I mean, I think the biggest humanoid robot that I've seen on the street was in China, and it was a police robot, and it was a walking, talking type of robot, but it was based on commands. It wasn't interactive. It couldn't tell me I had a blue shirt on, for example.
Right. Yeah. So you guys have some of you are at UT, right? Yeah. Go back here. So you got robots on campus, it's delivery robots, or at least you did. They're still there. They're working okay, right? So their job is to just take a meal from one place to another, typically, right? Or small goods, that kind of stuff, and they're running around on the sidewalks. Let's say, right? They're optimized for running on sidewalks, and they're aware of people around them. They're using ultrasonic sensors. They're using a variety of different sensors. A lot of them are using a certain kind of radio type sensor that can detect human presence.
They can talk too.
They can talk.
I can make it stuff as well.
Well, they ask for help.
And how
Like,
do you
can you
help them?
get me over the curve, kind of a thing, right? Exactly. So it's becoming more and more commonplace, and so we just need to be able to keep evolving what that interaction looks like to lower the friction, because there's going to be friction. Yeah.
So the first robot that I wrote, it was a pretty crude robot that I experienced in a commercial environment. I started working at Texas Instruments at their plant in Lubbock, and they had a mail cart robot. It was about this deep and this wide and about this tall, and it followed. All their stuff had no shag carpet, and they had a magnetic, path that they put down. It would go by every secretary's area, and it would stop, and then she would, take mail off from the mailroom and put stuff back on. And it had obstacle detection, so if you walked in front of it, it wouldn't run over you. And so, back then that was really advanced. Obviously, it's really improved by today's standards. This kind of neat. It would beep periodically to let you know it's coming.
I'm gonna show you this. This is not what my robot's doing, right? Because my robot is doing sort of, the whole idea is to do higher level planning and types of interactions and discussion, but it's not to have like real fine level motor control over the arm. There's a whole new range of LLM driven things. It's called VLA. So those are vision, language, action models. And the action is the one that usually receives the most fine tuning after the fact, because that's the one that's the most different, like specific to a task on hand. So these aren't focused on voice, but I'm going to show you this. This is a company called Physical Intelligence, and this is what they're doing. Anyways, maybe. Oh, yes. Oh, and we don't actually have to have audio on board. So you saw it actually open up a dryer, pull clothing out. It's going to put it on this bench. It's going to start sorting them. Right, it's going to end up having problems with the blue shirt. It's always the blue shirt. It's actually, I think it's lavender. All right, so it's going to have some problems with this one, but it'll still figure it out, right? So this is an AI doing really fine motor control to figure out how to fold laundry. This stuff is happening, and this is on a local. It's still a very high-end graphics card in the local environment. But these kinds of things would probably have hundreds of local training runs on how to find the corners of clothing and different kinds of strategies they can do for folding them, right? So AI and robotics is hand in hand, hand in glove. You're not going to be able to avoid integrating them going forward, I think, at some point. So it's just, I thought it was time to jump on the bandwagon. So we'll share the slide deck if you're interested in it. And I'm sorry things didn't go smoothly today, but it's finally behaving, at the last minute. So.
You're on the bleeding edge, so we expect things, demo syndrome to happen.
Super cool.
Yeah, super cool. Thank you for reading it.
In here, it's going to I'm going to remount everything on this platform here, and all this stuff is mounted so that it should fit underneath inside of this cabin space here. It should all be sealed up. And this will poke through the ceiling. Either I'm going to mount this on the ceiling or I'm going to cut a hole and poke it through the ceiling. I haven't decided how I'm going to do it yet.
So you'd have to adjust the programming on the camera so that it can go through the tints on the plastic window.
I hope not. But the one thing I did do is these sensors here have I put a clear polycarbonate on it to protect these sensors here, because those are raw semiconductor elements. And out in the field, well, you don't have to light very long. So I'm going to make better holders for these polycarbonates. But this is like, oh, does it work? And it's like, I put it on there and it didn't seem to affect the performance. But on the manufacturer's website, it says, for the sensor part, it says that use polycarbonate, make it as thin as you can. Yes.
So what parts did you 3D print? Line 3D print?
Oh, I 3D printed this holder, of course. On the final version, it's going to be sealed up and it'll mount on the front here. So, and right now it's just open and taped on the bumpers. So this will be a nice 3D printed version, and then all the holders for these sensors here are 3D printed. And then there's a odometry wheel on here. I had to build a big 3D thing to mount it, to push it against the drive shaft to get some feedback. Because there wasn't any good feedback. I had to go put my own odometry on there.
And what's the material you use to print it?
Right now I'm just prototyping with PLA.
PLA.
Yeah. But I need to reprint everything.
Yeah. Nylon.
And I might do it with PETG. That's probably good enough for what I need.
Heat resistant.
Yeah.
Texas heat resistant.
Right. Yeah. So it can run for like with 2 batteries, which is
That's helpful, shouldn't it? Homemaker's pack.
10,000 milliamp hours at 11 volts, 12 volts. I can run all of this for about 2 hours.
Okay.
Wow.
So,
all this stuff.
I just got this a couple weeks ago. Ordered it from Maker's Pack. It's about the cheapest ROS compatible robot that you can find.
The motors and stuff take about less power than this stuff.
Wow. Thank you.
So I guess the instantaneous currents on the motors would be a lot higher.
So
The average power.
So just to quantify inexpensive,
pretty cool.
because
Yeah.
robot. Thank you.
Yeah. I have a question about the course. You know, when you do your obstacle course,
So
I'm assuming that no one,
$150
no a priori map
for a robot. And you give them, it goes down. You give them the GPS coordinates. What you can do is and configure it. You may choose to, so you can set waypoints or may not, depending on how confident you feel with your robot's ability to handle driver board, the terrain. There are obstacle motors in between the cones, LiDAR sensor, go around 3D printed parts. So you can deselect some of these. Somewhere there's some you don't want a LiDAR or don't want plumbing and so want to print your own parts.
The reason I ask is because he's got the GPS on.
So it's
to help because he's going to get information
on AliExpress. You can find ROS compatible robots for maybe 100. If you don't have GPS, this is about as low as rely on dead reckoning. And but the reason it's so inexpensive is that it's got this. I shouldn't. Quite a few people. Several people have, including based on an ESP32 microroboticists in the club Verily have Wi-Fi to use a regular GPS to, not RTK, but regular GPS to the general area. Microcontroller runs the Arduino AI, so you program it using the Arduino programmer to find the cone and then seek to the cone. Within that, once it gets running on top of Arduino, is something called MicroROS. And MicroROS is a piece of the AI software does a pretty good job that exposes topics
are you allowed to set up the infrastructure for RTK?
To ROS, absolutely, out in the cloud somewhere, or on a laptop. So specifically here, I'm going to turn this thing on here. From the sublime to the tiny. And I want to show this thing. It's called a Maker's. And turn it on, and I'll pass it around. But I want to do a demo. I want to demo it first. So it's now doing a slow flashing. It's connected to Wi-Fi. I've got a little router, baby travel router down there. That it's connected to, and it's I programmed it with the IP of my laptop. So at this point, I'm going to disconnect my laptop from the Dallas Makerspace, and that means that my sharing will stop.
You want me to hold it in front of the camera? Put it on the camera?
Yeah, or I can keep it up I'll keep it up on the screen because it doesn't rely on like going to switch over to 129 spare is the travel router. And so with any luck, so now what's going to happen is, as a part of this Maker's Pet product, they provide Docker container, a Docker container that has ROS2 in the Docker container. So you launch the Docker container, and then it's running Ubuntu 22.04 with ROS inside it. So then you can, and ROS is installed inside of that, so you can launch ROS programs. So what I hope to do here is to demonstrate map making and navigation within a map. So that's a lot of power for, you know, $150 robot, but really you get that power because only the very lowest level, machine control level, is running on the robot, on the microcontroller. All the path planning and motion control is running up on the laptop in a Docker container. One of the other neat things about this Maker's Pet is it runs on Windows because it runs in a Docker container. So they provide instructions for. So I want to just give you a brief. Oh, I can't get to the slide. Sorry, I quit too early. But just they give you like about 8 videos that step you through assembling the thing, programming the firmware with the Arduino firmware, firing up the Docker container, making a map, and so forth. And so because it uses a container, you can run it on Windows under WSL2. So a lot of things to like about it. By the way, I have no connection with Maker's Pet. I'm not trying to sell anything. I just think it's pretty neat. So
does it run your Arduino robot?
Not currently. So okay. So maybe let me just, since Dave had asked Mike to state a little bit about his background, let me state a little bit about my background. And so I was grew up as a double E doing board design, done some basic designs. Then I became system architect, and then after a while I moved into robotics, went to DPRG in 2007. 2012, 13, I went professional in robotics on self-driving trucks, and worked 9 years for several companies doing autonomous full-size vehicles, and maintained my connection to the DPRG throughout. And yes, so that's my experience. So and then that's right. Mike asked about Lino Robot. I'm currently a maintainer on a software stack called Lino Robot. If you look on the web for Lino Robot, you'll find some GitHub repos with and what Lino Robot is from a software standpoint. It's the same thing as this Maker's Pet. It's just a different implementation. I'm just going to draw it real quick.
Is that Lino?
Lino, Lino Robot. I believe it's linorobot.com or something. So conceptually, Lino Robot consists of ROS2 software, which, as you can appreciate, could run anywhere on a network, but wants to run on an Ubuntu 22.04. And then there's a link, which could be serial or Wi-Fi. So this implementation uses Wi-Fi to a microcontroller running micro-ROS, and then there are sensors and motors off of the microcontroller. And so what micro-ROS does is it exposes the sensors, exposes the motors. Oh, the LiDAR goes in. LiDAR can go direct. If this is an onboard robot like a Raspberry Pi, then you plug the LiDAR straight into the Raspberry Pi. Or it can go through through some kind of transport mechanism through the microcontroller, which is how this implementation is doing it. So conceptually, this is the ROS plus micro-ROS architecture. Neo robot is this, and that robot is this also, with ROS running in a container on laptop versus on a Raspberry Pi, which would be the other place it could run.
Yeah, like my implementation is architecturally the same, except I use hard serial ports and I don't run micro-ROS, it's done with microcontrollers. Because when I was just demonstrating this, I had 3 microcontrollers, but they all have just a serial and they run JSON protocol.
Okay, so I've got I've got a container launched here, and so I'm going to ROS launch the KIA bring up physical.launch file, and hopefully the white light will start flashing, and it did, quick flashing. So that indicates that, hey Carl, that indicates that the microcontroller firmware, micro-ROS on the microcontroller firmware, has established contact with the ROS2 agent running in the Docker container on my laptop, and is now publishing odometry and LiDAR data and all of that jazz to hopefully make it work. So now we can do we can run KI teleop keyboard, and hopefully it will run. Here we go. We can like make it turn. Okay, so that's teleop through ROS. So now let's get a bit more sophisticated. Okay, we're going to now run ROS2 launch KIA bring up navigation.launch slam equals true. Who knows here knows what slam is? Okay, let me just do a brief overview then. SLAM, simultaneous localization and mapping, is a fundamental technique in robotics for creating maps and localizing where it is in the map. So it uses the LiDAR, and I'm going to place it down on the floor here, and I want to put it sort of up against the wall here, so it ends up developing a reference, and that has some solid edges to it, because if I put it in the middle where the tables are, all the table legs look the same, and it's really hard to tell where it is. So when I start up, oops, that's good. It's starting to come up and me anyway.
And so when I'm running like on the outdoor competition, we don't have a map. I'm not going to make a map. I'm just making an obstacle map on the fly as I'm roaming around. So it makes it a little more challenging to come up with a route. But it'll do the route as good as it can, it'll follow it, and then, oh, there's an obstacle there, so it'll reroute around it. Yeah.
Hubs won't stay launched. It's kind of a problem. What to do about that? Let's see. Relaunching it. Relaunching this stuff. And I think I need to restart the robot to get it to connect. Nice thing about having the microcontroller, only a microcontroller on the robot, is it boots like super fast, as opposed to Raspberry Pi. Okay, so what we're seeing here is the LiDAR map. The robot's facing forward, so it's facing in that direction. This is the wall, and this sort of black bit, this thing here is the wheel of the stand. So now I'm going to drive it a little bit, and you'll see that the LiDAR fills in this space and some of these empty spots here. And what we're trying to do in SLAM is to give the map a complete picture of, clean picture of all the open space in the map, and also where walls are. And then when we save the map, where the walls are detected will be recorded as do not cross this. It'll be an obstacle to path planning. So we'll keyboard tele off, and we'll drive it forward a little bit. And you should start to see it fill in here, I think. Not seeing that. I don't know why it's starting to fill in here a bit. And we'll steer it around a bit. There we go. Now it's starting to fill in the gap behind that leg.
Slow it down a bit. I can't follow.
Okay, that'll do for a map. So now we should be able to navigate within the map. So let me just stop it and exit this, and we'll save the map. So what we're going to do here is,
segment.
Yeah.
So is the map like a custom file, or is it like?
It's actually a PNG. So it's a real binary file. And so we're going to run ROS2 run nav2 map server saver CLI -f, and then the name of the map file. So we'll call it makerspace ms map. Save map with timeout. Okay. Okay, so now if we do an ls on /root/map, okay. It's a PNG file. I was going to show it, but actually, yeah. Now I want to navigate within the map. So we'll exit SLAM mode. And restart navigation.launch. This time saying map equals home/maps/msmap.yaml.
And why did our biz not come up? Oh, we click on the file on the PNG.
Maybe it's saved somewhere else.
Yeah, let me just check. Okay.
Second time's the charm.
The demo effect has been has been overcome. And so you can see this is the wall, and here's the wheel on the post, and this bar would be this horizontal thing. And it looks to me, so now what we do to navigate inside of the map is we first of all tell Ross the initial pose of the robot. So we'll set the 2D pose estimate, and it looks to me like it's about here facing this way. And if you look here, you can see the LiDAR scan overlaid on the black. So the black is where the mapping process created map boundaries, walls and obstacles we're detecting. So you can see my initial guess at a position is just a little bit to the right, to the left, but not bad. We can do a little bit better, but pose estimate, I'll just move it back a little bit and up a little bit. That's what it looks like.
How do you pronounce your?
There we are. So now this LiDAR scan matches this one close, and this one pretty close to this. So now we should be able to ask it to navigate somewhere. So we will say nav2 goal, and let's ask it to navigate up here. And off it goes. Yay! Navigation within a map. It doesn't seem to have obstacle detection enabled in this software.
So is it path plan around the?
Yep, it's done path planning the whole 9 yards here. So let's ask it to go somewhere. Oh, it's still trying to find the final goal that it wants to seek to.
If you were to like kick it, would it find where it's supposed to be on the map, or would it just assume where it's supposed to be?
I'm sorry, say that again.
So like if you were to move it while it's in the middle of path planning, does it know where it is for that space?
No. SLAM is a kind of an incremental process where, so let me give you a better answer to that. So see this set of green dots around the robot. That's a particle filter that's filtering the incoming LiDAR data to try and determine the most likely position of the robot. So it's pretty well clumped around the robot here. Initially, before I told it where it was, there was like a pretty broad range of green dots. So as it moves along, each dot in the particle filter says, how likely is it that this is the current position where the robot is based on the LiDAR measurements and the map. So it's continually updating its position so that if some of the odometry is inaccurate, for example, or if it had an IMU that wasn't correctly showing exactly how much it turned, it adapts to that. So it's quite a robust, SLAM is like a really robust way of navigating within a map. So that's what I hope to show was SLAM in ROS on a $150 robot. And you can, if you don't buy the LiDAR, you can get down to 100 if you don't want this whole SLAM thing. But this is pretty impressive. So anyway, that's my show and tell.